It's all about data. AI, mission-critical applications, ransomware protection, data is at the heart of everything, which is why it's so important to manage it, protect it, and use it to bring dazzling new insights to life. It's time to take your data and business to the next level. The new NetApp AFFA series. Powerful, intelligent, secure. Turbocharging the workloads that make your business work? Check. Turning AI and Gen AI opportunities into reality with data-driven intelligence and future-proof infrastructure? Check. Keeping your data safe with the most secure storage on the planet so you can sleep at night? Absolutely. All made possible with the same leading NetApp ONTAP data management software trusted by the world's biggest companies and largest public clouds. Capable of 40 million IOPS and 1 terabyte per second of throughput in a single cluster. Supports block, file, and object seamlessly integrated across hybrid multi-cloud. Built-in, real-time ransomware detection designed for industry-first 99% plus accuracy. The new NetApp AFFA series, unified data storage, built for the AI era.
Hello, everyone, and welcome back to NetApp On Air. As always, I'm your host, Nick Howell. Thank you so much for joining us. We've been off for about a month getting things together for 2025, and boy, I'm excited about this one for you. We're hot off the heels of a massive NVIDIA GTC conference last week. Intel Innovation is going on this week, and all things are pointing to even more AI stuff this year. So we've got to get into some of the AI concepts so that all of you are prepared and are aware of all of the things that we do here at NetApp around AI, around data science, and much, much more. First and foremost, a little bit of housekeeping. If you haven't joined us yet, make sure you get into our Discord community over at netappdiscord.com, or you can go to discord.gg/NetApp if you already have an account and already set up and familiar with it. There's over 5,000, almost 6,000 people in there now, mixing it up, helping solve each other's problems. It's a true community, and we love being a part of it and having everyone in there helping each other out. We've got our partners in there. We've got some of our solution architects, like our guest today. Some of our executives hang out in there, and I promise you, like, our product managers are in there watching what you guys are talking about. So, like, if you're in there giving feedback and things like that, it's one of the most productive ways to give direct feedback about our products, services, and solutions out there. Discord.gg/NetApp or netappdiscord.com. As I said in the beginning, AI is still the thing. We're still talking about it 2 or 3 years later. It's not a fad. It's not going anywhere. It's here to stay, and it's going to be a big part of our lives here in IT and in technology now and in the future. So we need to get familiar with some of the concepts of it. One of the most important ones that I've come across is what's going on with databases. And over the course of the last decade-ish or so, there's been a lot of advancements around how databases are deployed and managed, specifically vector databases and how those interact in the cloud, things like that. So I wanted to bring someone on today to talk about it in the context of AI and how it leads into that stuff, specifically around data science. So he actually reached out to me yesterday, or we were having a conversation about Postgres, some things that I'm doing here in the home lab, and he said, "Hey, I got an idea for the show." And I was like, "Hey, that's perfect." So welcome to the show, everybody. Minith Patel. Minith, how you doing, man?
Yeah, I'm doing good. How are you?
I am fantastic. I'm excited to talk to you and hang out with you some more. Yesterday, I was doing some home lab work around Postgres, familiarizing myself with it. I'm an old Oracle MS SQL traditionalist, kind of. I understand those concepts. But when you get into some of these, it gets a little tricky. How you lay out the storage, how you lay out the infrastructure, database protection, synchronization, things like that change a little bit when you get into some of these, especially if it's not hosted on traditional infrastructure. So I love that you suggested this topic. It's perfect timing for it coming off of GTC. If you're looking for information of GTC, hang tight. Those are coming in the next couple of weeks. We're going to go have specialists on here talking about all of the announcements that we did last week at GTC. But Minith, you brought me the topic of vector DBs. Why is that important? Why should people, in a nutshell, why should people care about that?
It is an integral part of the AI lifecycle. So that's why it's essential to understand at least what is this new database that has evolved to help and assist AI so that we can, as part of the tech community, we can understand the working mechanisms of it. Full disclaimer here, this is like, a data scientist concept when it comes to vector database. We'll learn a few things from level 100 perspective, because, ultimately this is all about math and statistics and geometry, end of the day, on how data is stored and retrieved for different AI processes.
And, I think one of the things that we really want to focus on today is some of the infrastructure concepts that may come into play that our audience might find valuable, as far as, what's required of you. The things to think about, the way I look at this is there's two different personas here. There's two different audiences. There is the data scientist, the people doing all of the math. And then there's the infrastructure and IT folks that are supporting the systems, providing the space for them to do all of that work. And it's almost two different things you have to serve. You have to provide the tools and the capabilities, but you also have to protect it, back it up, right? You got to make sure it's performant and reliable and up and available and all of that stuff. So I think there's two different parallel paths here that we could talk about this in. But I really want to hand the floor to you and just kind of let you take us through what you think people should know.
Okay. Yeah, we'll go. Can we share the screen?
Yeah, go for it.
Yeah, so I do have a kind of agenda. I've used this as an internal enablement. So these PowerPoint slides are going to be a little text heavy, and it will have links to it as well.
Yeah.
So that if you wanted to dive in deeper into certain topics, subjects, or any architectural diagrams that you see, you can use that. But to answer your other question, yes, we'll talk about infrastructure needs. Even we'll talk about, hey, where does GPU, the buzzword, comes into picture, right? How do we leverage that for faster processing? What is faster processing, right? So we'll learn different types of vector database, how they can be used in different scenarios. Do we want to do in-house, cloud subscription, hybrid approach? So we'll look at what's out there, what are the types, and how they are evolving over the last few years. So with AI, there are many disciplines in AI. As you can see from this picture right here, the one that drove vector database into existence was for the RAG process, which normally helps with the natural language processing, which means if I am a regular user, and that's where IT is going, is it's eliminating complications for end users, and that's what AI is being used for. So as an end user, I understand my data. As a finance person, I understand my data. Now I want to create a database for it. I want to do something around it. How can I use natural language processing, right? Create me a database and give me such and such data from Q1. And if they are a little advanced, they can say, can you combine it with this another data set, all by using natural language processing. So that's when RAG comes into picture, and that's where vector database also comes into picture.
So what is RAG for people that might not know? What does that mean to someone that might just work in IT and not understand these concepts?
So RAG is a process where you have three elements to it. As you can see right here in this picture, I'll just refer to that. The three elements are, there's an embedding model, there's vector database, and there's LLMs. What they do is whatever inputs you provide, this is the lang chain, or this is the formula, or this is the process that will take the data that you provide. It can be images, videos, or whatever, and then you can have natural language interactions with it. The easiest example that we know today is ChatGPT.
Mm-hmm.
Now, every organization has their own in-house built ChatGPT, right? At NetApp, we have something called NetChat AI, where you can upload a PDF or whatever document, and you can write queries against it, or you can ask queries against it. If you don't want to type, there's a mic button right next to it, right?
Yeah.
So You can do all of that, and this is what comes behind the scene.
So any company out there could take their data and take a model, build a model around their data, and then interact with it privately without having to go out to the thing. That's, to me, that's the differentiator with RAG, is like you're doing it with your own stuff, and you're doing it internal within the walls and the confines and security of your own enterprise.
Correct. And we'll look at different use cases too. Think of it like, Netflix using it as a recommender system. You log into your profile based on your history. They recommend you certain movies because, this is what you watched. 10 other people who watched the same movies as you watched this movie next. So let me give you that movie next. And that is what that system is designed to do. And there are many applications where this RAG process comes into picture. But long story short, keeping it very simple, when you use a RAG model, there's embedding models, again, a third-party solution that you have to get externally. And these are like, think of OpenAI, ChatGPT, Hugging Face, that's an embedding model. The job of embedding model is to take whatever data you're providing it and create a vector data point associated to that data. And in few slides, I'll cover that, like what is a vectorized data and how it's stored in vector database and how does AI use it? Because this can get too complex too soon.
Yeah. Well, we're assuming that our audience, for those of you watching this either live here or in the future, we're assuming that you're probably not DBAs. And we're assuming that you're most likely ONTAP practitioners, hardware and software practitioners. So we want to go into this with sort of what are some of the things that you need to be aware of going forward in order to set yourselves up for success when it comes to building out your infrastructure? And what are some of the tools and things that ONTAP can provide and enable to make things like this really successful?
Yep. We're going to take this at level 100, make it very easy to digest certain concepts. Like, if somebody says embedding model, at a very high level, we need to know, okay, it's going to take data and create vector embeddings for it. That vector embedding gets stored in vector database. And then there are large language models that can interact with it and give you the output that you need or you're looking for. So vector database, integral part of AI, and this can be used for many other things other than RAG as well. In future, we're going to have disaggregated storage architecture for NetApp, right? And for that, you need faster search capability of any volume, any files within a volume, hosted in any corner of the planet, right, on a NetApp controller. How do we get that data set fastly, efficiently? So that is also going to leverage the concept of vector database behind the scene, because as data gets understood by these models or the RAG process, then it's faster for us to retrieve it. So it's, huge data set. I want something, let's go get it.
Nice. All right, so where do we go from here? Oh, this looks fun. This looks like physics in my sophomore year of college.
No, so this is just a basic evolution of data over the last 20 years or so. So, the biggest buzzword 20 years ago was three-dimensional data sets, OLAP cubes. And that was like, wow, fantastic, solves very good business problems that we have. Good, data kept evolving. And then 10 years later, I'm just giving a rough estimate time frame as an example of the journey of data evolution. So 10 years after that, we saw, hey, we have so much data. In comes the concept of data lakes. Like, hey, we have enough warehouses. Now I can't just keep it or something like that. So that's when we introduced the concept of machine learning, because we have so much. Now we have to make the most out of that data and use it in the best way so that we get a good return of investment. One example I can give regarding that in my experience. So about 12 years ago, I worked for a mining company, and it was they have mine pits here in Arizona. I'm from Phoenix, Arizona. There are mines here in Arizona, about 4 or 5 different sites anyways. And these are not the mines that we think of when you watch movies like tunnels. No, these are open pit mines, right? They dig from the top of the mountain and, just open it basically, because everything is within those mountains. So in order to excavate, mining companies use these huge Caterpillar trucks. You might have seen them, right? Huge tires, like, 20, 25 feet high. So
I watch Gold Rush. I never miss an episode.
cool. So these cat trucks are millions of dollars.
Yeah.
And the tires that they have are hundreds of thousands of dollars. And and this is 12 years ago, in order to order those tires, those are custom built. There's, again, supply chain involved. These specialty tires takes a long time. So what we did back then, I was part of this project where we used Hadoop, because Hadoop was the buzzword again back then as a data lake platform. We wanted to solve the problem is how much will the tire thread level wear out, to what level it needs to wear out, that we get an automatic notification and we can order the tires, with whatever supplier it is, because it'll take 6-8 months. So in order to do that,
programmatically determining the age and how long they would last based on the workload they were doing. Yeah.
Correct. So a lot of things involved in it: sensor data, soil samples, atmosphere, different daily runs and loads and all that. So non-generic data, non-conventional data, which in today's sense with sensors and all, it's coined as IoT, right? So it's a combination of traditional data set and IoT data. Then we brought in data scientists who were experts in machine learning, and they wrote algorithms that give us that output that we needed, basically. So fast forward to today, the same algorithm or similar concept of writing that algorithm has now been commercialized. And you can think of those kind of like an embedding model that's going to do certain things for you, analyze your data set for you, and create different categories on how these data can be interpreted for you. And that's where AI-based database comes into picture. And that's right. And as we know, not only data size is changing, but data types are also evolving. Right, we see the need of kind of like S3, another place to keep your data. We see, people using audio, video, different formats of data, images. All of those, now we need to make sense of it. So cat truck, just an example, from a decade ago. Now everybody wants to do this for their applications, for their relevant industry, and leverage that. And that's what AI helps with. This helps automate a lot of it with those algorithms that are provided as part of embeddings, and also provided as part of the LLM models.
So what's the difference between what we used to do versus what a vector database does? I don't think we've gone over what even is a vector database and what makes it a vector database. Oh, you have a slide for it. Perfect.
Perfect. It's lined up, segueing right. I like that.
Nice.
All right. So think of vector database as these LLM models are going to generate these data points for you. In this example, let's look at this example right there. You have a cat, dog, and a wolf. What are the similar features of cat, dog, and a wolf? Paws, right?
4 legs.
Ears, furs, tail, right? Those are all similar aspects. So there can be so many data points that can be similar. What are distinguishing features of them that make them unique, to what they are? Why do we need to know? Because you're training AI, or so-called algorithm, to understand and differentiate between these aspects of an animal in this case. And that's what vector data is. So LLM models embedding models are going to create this vector data points for you. And that's what it is. So think of it this way, ID 1001, we have 1, 2, 3, 4, 5, 6, 7, 9 vectors right now that represent maybe a cat. Then, 1002, again, 9. There'll always be the same dimensions in a table. And this is just a very simple example. These dimensions right now in this example is 9. It'll never be that low. It'll be in hundreds or thousands associated to one specific data point. So think of it like when you use chat and you upload a PDF, you get vectorized data created associated to it. And that is what gets stored into this vector. And AI is designed, these LLMs are designed to sift through this huge dimensions of data that have been carved out by logic, right? It is similar, it has correct semantic meaning to it. And that's, in essence, what is being stored in these vector data. Sorry.
No, it's a good point to ask a couple of questions. I'm not trying to be a DBA here, nor do I think a lot of people in our audience are trying to be DBAs. But how does this differ from an infrastructure standpoint and setting up and supporting this? Are these IDs, these vector IDs and endpoints, do they still exist in like traditional tables? Are you still running select statements to do queries and things like that?
They can now. So we'll look at different vector database types, go over them just to understand, like, okay, fine. So there's something called embedding model that generate these vector data, and we're using it to create output for us. Fine. What are my options? Can I do the same thing in MySQL Server or Oracle, or do I have to buy another product that is created especially for vector database? So I have a few slides coming up for that where we'll talk about different types, because they matter too on what the search capability is provided by different vector databases. So we'll talk about that as well.
Okay.
But, yeah. I mean, so far you're with me, right?
I'm with you. Yeah.
All right. So same thing right here, more examples so that we can correlate more, make it, part of a norm to understand this concept. Here we have, again, there are multiple things, files, audio, video, whatever it can be. So think of a healthcare provider. For a patient, they have MRI records, X-rays, heartbeats, whatever they're monitoring, whatever they're testing, blood samples, this and that. Now they have to make sense of it as a whole to diagnose a patient. So
they might have doctor recordings of notes that they have on patients and things like that. Yeah, a former healthcare guy here. This is really hitting home for me. Yeah, but we used to do all of this in Oracle, 20 years ago.
So that's what is going to be automated via an AI, which will be a process that's created with certain predetermined factors, and it's going to tell doctors like, hey, based on all the records that we see, this is close to this kind of disease, or this is what we need to prescribe, or this are the next steps. And then doctors can make decisions based on that. So it's helping in certain ways. So different ways.
So in your opinion, is AI is it kind of taking over what would be the traditional middleware stack in a layout where your AI and machine learning have kind of wholesale replaced the need for those, or they've just come in and, with new products? So it's almost in a sense of the tail wagging the dog, like the middleware is driving the innovation in the database, or is it the other way around? Am I missing something?
It's the end user driving the innovation in database.
Okay.
End user wants to be more close to the core database without actually learning about the core mechanism, right? Same thing with software development. Yes, we have utmost need of data scientists, but if they can give us something, if they can create something for us as programmers, we can leverage that and do multiple things with it. So that's what AI is. It's just helping eliminate, like you said, the middle structure. A decade ago or so, we had people who would just document projects.
Yeah.
We don't have those anymore, right? So
no, and now we've got Hugging Face that has a lot of this stuff like pre-built that you just go and like plug in an API and it just works. And it's amazing to see some of this stuff in action. Yeah.
Yep. Yeah, so that's what vector database is. It's another database. We'll look at the use cases and personas who will be touching it. We'll look at the infrastructure also that will be involved in it, how GPUs and everything can be leveraged. But here are a few different architectural diagrams that just help us understand, like, okay, something's coming in, gets vectorized, gets stored in the vector database. So as an infrastructure guy, I mostly care about vector database as a conventional database. It's going to be installed on a platform. Mostly it's going to be installed on multiple VMs or containers, depending on what the company decides to do or whatever the choice is. But it's going to be just like another application. The only difference is very limited people will be using it, because if it's a relational traditional database, a lot of people can now use it, right? Understand it.
Yeah, it's a lot of people can write select statements and write SQL queries and stuff like that now. Whereas 20 years ago, it was like that was very specialized, and you better not touch that or you'll nuke the whole database. Which that still happens. Don't get me wrong, but I do like that there is this new layer of middleware that allows kind of higher level user interaction directly with the data, even though they're not sitting at a SQL prompt writing select statements. They're using things like I keep referencing Hugging Face, but it's probably one of the more prominent ones, or where that application is directly interacting with the database, and there's the translation process that's happening from the vector data into real language that they can use and talk to. So that's what I look at it like. That the step one right there, where it transforms raw unstructured data into vectors and then takes those and gives them embeddings to put into the database. I think that's as far as a typical end user is probably going to see without having direct access to the database itself.
Yeah, they don't have to see any of that, because once it's vectorized, Oracle AI provides the ability to host these in Oracle.
Yeah, it's basically indexing work that just is scans that run ultimately, right?
Yep, you're correct. And that's the segue to the next slide.
There we go.
The core basics.
I promise we didn't pre-plan this.
Yeah. So core basics of a database, a place to house the data, which is a table, or or a bucket, or it's changing. Definition is changing, but it's a place where you will house something. In vector database, it's still going to be a table with an ID that represents certain data associated to it. Another thing with vector database is the index. There are different index types, and that is the differentiating feature of a vector database.
Yeah.
But that's the core basics of a vector database. So again, more architectural slides to reinforce the same fact. Again, you can think of it more, process that you can see through this image right there. Ask question, user query, or ask more questions to it. What happens? This is an example of chat. So you upload a document, what's going to happen? It's going to go through an embedding model. That embedding model is going to give vectors. It's going to go in database. Then it's going to interact with LLM that has been crafted, and it has certain knowledge in it. So based on your query, you're going to get a response. And if you're going to get the same response or the same query from multiple people, you can cache it, basically. Yeah. You can keep your cache sizes more. There's more advanced, learning that's involved in cache. That query is going to be static, we see a very fair amount of, or large number of people using the same questions in the chat application, then we need to do something about it, right? Everybody needs to know. then there are flags that can be created and a process can be created, and you can send emails like, here, this is what everybody wanted. We can do this for you guys.
So
So
let me ask you a question right there. What are the most prominent vector databases that you're seeing out there currently? I saw you had Pinecone and Redis mentioned along with
Yeah.
Milvus. I guess I was just curious, like, what should people be on the lookout for? What do they really need to be researching? Because when I think about it through the lens of our audience, it's kind of like, okay, I need to figure out how to install and support that particular vector database, or I need to go ask our DBAs or our data scientists which one they're familiar with, which one they want to work with, so I can go learn the deployment parts and the protection parts of it. So yeah,
Right.
what are you seeing out there?
So right now, I mean, these are different categories of vector database that you can see, right? They're pure vector database that were created to assist massive, huge RAG processes. So think of production, live interaction of RAG process by end users. Netflix again, and just a simple example where things need to happen real time, really fast on magnitude of data that's been out there. So that's where pure vector databases come into picture. You can leverage that and the multiple indexing capability that it provides, indexing and search capability. All search related to vector is going to be mostly around similarity search. What is similar to this? What is similar to this object, or what is similar to this data? And if you don't have images, there's text search databases, that's crafted specifically for it, faster, linear, easier to absorb. There are NoSQL databases that are now taking in, like, hey, end of the day, it's a table, right? Let me absorb it. Use us, let us host it. So integration APIs enhanced for the embedding models that's going to provide these tables, vector tables. So if you have an existing infrastructure, you can research and see what your searches are going to be, what your indexing is going to be, and if that can be accommodated by your existing NoSQL or SQL capable database. If not, chances are you're going to go to the traditional one.
Yeah.
At NetApp, we have tried, like we use for our chat AI, we use Vivid for performance benchmarking and testing, and our best practices guide. We had to pick one. We picked Milvus again because Milvus and Zizzle are good with NVIDIA.
Oh, nice. Okay.
Whatever works good with NVIDIA, we want to definitely use that, or at least test it in-house and see how it performs.
Yeah.
So too many types of databases.
With all love to AMD and Intel.
Yes. I mean, Broadcom's coming up with their, what are they calling? XPUs.
We'll see.
And that's going to
I'm more interested to see what ARM's up to. So let's put a pin in that one, because you'll send me down a whole rabbit hole of chip processing. I love that we're using those as pure vectors. I know there's some other elements of Oracle that obviously every large company is going to have as well. Cassandra, since it's been out, has changed how cloud and streaming services work. There's just so much evolution happening with databases right now. Are you familiar with anything of where, so I don't want to put you on the spot here. Maybe we need to get some of the Instacluster folks on, but where does Instacluster fit into this picture as a service for NetApp, if you had to pinpoint it?
Right here, Postgres. So they're really good with, Postgres has a vector database extension called PG Vector, and Instacluster is really good with it. So there are a few use cases that, they have showcased that can help customers understand how Instacluster can come in and be leveraged with Postgres.
It's kind of
for AI.
Postgres as a service, if you will, right?
Yes.
Yeah. Nice.
Yep. Few things regarding the vector database, since we are talking about so many types of database, right? And they keep evolving. And so there's open source. Some of them are open source. Most of them are proprietary because obviously they want to cache more on it. That's okay. But the key thing is indexing type, similarity function that these provide, and the storage model. How much of these do you want in memory versus on disk, just committed, or you want a
Yes.
mix of these, basically?
Want all of it in memory.
Or all of it in memory. I mean, eventually it will be committed to the disk, but yes, like Redis is known for in memory. So it'll have a bigger cache size, and that's what their MO and specialty is.
It's one of the things I enjoy about Postgres as well. You can set up the shared size so that basically so for my server that I've set up here for my home lab, I have 64 gigs of RAM in it. And I think I told it at 40 right now. I just want to load everything into memory and leave it there. And I remember going through some of that in like old Sun Gear and like some, late 2000s Linux hosts where we were oversubscribing the amount of memory to Oracle. We were putting like 500 gigs of RAM in each host and giving Oracle half of that.
Wow.
And just so that we could like load multiple copies of the instances fully into memory, and then just flush to disk as we needed to. I think a lot of those practices are changing though as things become more real time. Eventual consistency with Cassandra changed the game a little bit. You still have strict consistency with Oracle and other SQL platforms and stuff, but like I think the dependency on strict consistency has waned a little bit. That's one of the trends that I've seen. We seem to be more comfortable with, okay, we can backfill those updates down the road in other sites.
Yep. So queuing mechanism is getting better. Let's put it that way.
Yeah.
And it's getting really better with, well, Cassandra is good for that. And capturing every single event is getting more importance, and just queuing it back in. So no matter what happens, and any activity that occurs will get committed no matter what. If not this pod, then the other pod's going to grab it and commit it. And that's where the evolution is going. It's like high transactional environment. So and that's what I normally have conversations around with NetApp. Like, I work on help with MongoDB, Postgres, MySQL, so high scale databases and how they work. And if you have more specialty need, we have the InstaCluster team that can help you with other open source databases.
Yeah. Guys, don't sleep on InstaCluster. If you need help with this stuff, like frankly, they're a professional services organization for open source databases. And they also have a product that they manage, but like we have the ability to deliver services to you to help you with this stuff if you're not familiar with it, on-prem or in the cloud. So don't sleep on our InstaCluster stuff. That's yes, we do Oracle and SQL and Postgres and all kinds of stuff, and all of it's out there in the documentation. But if you need help beyond that, we've got the help. We can certainly provide that. Maybe you can get on the phone with Minith here, and he'll help you build it.
I can definitely help. If not, I can point you in the right direction. All right.
Well, this looks fun.
Yes. So now, so far, we just talked about basic, right? Embedding models, generate vector embeddings. Fine. How do we use them? We use them in search, basically. And this search functionality is what is going to be differentiating factor for your database. But how can I use this search for existing data set with my vector embeddings in Oracle, SQL, and SAP? That's where the evolution is happening, right? That's where the new stuff is happening. So we're going to pivot a little bit and talk about adoption of vector search capability in relational database. You think that's going to be cool? So
Not to non-DBAs.
not to non-DBAs.
Yeah. Like I love this as a visualization of what's actually happening behind the scenes, because it helps people like me plan for what I need to build to support what the DBAs are going to be asking for. That's
Correct.
kind of the perspective I look at it through. When I try to look through our customers, the lens, certainly we want to provide the best storage possible for databases, but we're not selling databases, right? We're selling the stuff that makes databases awesome and fast.
Correct.
And easy to work with and easy to protect and all of that stuff. So
And
I'm not sure that I'm ever going to log into Hugging Face and build a model, but I'll damn sure set up the infrastructure underneath so that the data scientists that are going to do that will have a good time doing it.
so that's where the evolution is going, right? It's going to be very easy. I know which model to get from Hugging. Cool. That's it. Write the Python script, attach it to a vector DB, and that's how you're doing it, basically. So it's becoming more and more commercialized and not as hard as it was a few years ago to understand it. This right here, just talks about the search functionality. Search again, this cosine, dot, Euclidean distance. These are the mechanisms or search mechanisms or similarity searches that come from the world of statistics, economics, geometry, to find, distancing.
I just got a little shiver because I haven't heard statistics and probability or statics and dynamics since college. So that was whew. Yeah. I remember Euclidean distance. I don't remember the other two. I'd have to go back and look. Manhattan distance. I don't remember what that one is. That's interesting. Now I need to go look some of these things up. Nope. Did we lose you, Minith? No, I think we froze up a little bit. Might have dropped. We'll give him a second to come back. All good. We're live. It happens. So I look at this as, I'll just waffle on here for just a second. In the late 2000s, one of the most complicated things that I was working on was virtualizing Oracle and MS SQL and Exchange, for that matter. And I remember a lot of the difficulties that I dealt with were breaking some of the practices that the DBAs were ingrained in the DBAs, right? Changing the way that they did things. That was the hardest part of the whole thing. Installing Oracle, easy. Virtualizing it, easy. It's still x86. So there's a psychological element to this as well. And if you have DBAs and app owners that come to you and say, we want to switch to something a little more online, something a little more vector instead of traditional RDBMS, like, okay. I want you guys to know like what you're signing up for and what you're agreeing to and those sorts of things. Because at the end of the day, like you're going to be the one that they come to complain to when the database is slow. And it could be because their query's terrible, but they're going to blame it on the hardware. They're going to blame it on the network. They're going to blame it on... So it's one of the reasons I wanted to bring Minith on today and talk about this was because it's one of those topics that crosses boundaries, that it's a bit of a gray area. It's kind of like blaming everything on DNS, right? You can always get caught up in those crosshairs of who's at fault for this. And like Minith was saying, we've gotten better messaging, better event logging, all of that stuff. I mean, hopefully everybody's got Splunk or at least some syslog server that they can see across their environment. But at the end of the day, you need to be aware of all of the things that are happening. And in order to do that, you got to be aware of these new concepts that are being brought in from all of this stuff. So we just got a message from Minith. His PC crashed. He'll be right back. So you get to hang out with me for just a minute. But anyway, we ended up virtualizing Oracle. And I had to change the hearts and minds of hardcore old school DBAs going away from Sun Spark based systems over to Linux x86 based systems because we wanted to put VMware on it. And I was giving them Linux VMs, Red Hat Enterprise Linux VMs. That alone blew their minds. That was the hardest hurdle to get over. So we just kind of did it, and we didn't tell them. And I worked with one of the DBAs to make copies of our database behind the scenes and did a little abracadabra one night, and they never noticed. They actually said things were running faster. What'd you guys do? And that's how we ended up disclosing to them that we had done it. And they loved it. They were on board. The big thing is they learned that their backups went from taking 8 hours to 58 seconds. Thanks, Snap Manager for Oracle. Oh, Darth. Hey, Darth. Good to see you, man. I wonder about Oracle in containers or Kates now, if anyone's doing that. You know, the middleware, yes. WebSphere and that kind of stuff, absolutely. The database itself, I don't think so. Listen, I haven't touched Oracle since, what was it, 11G, 10G or 11G? 2010, 2011. So I don't know what's happened in the last 15 years-ish with the new stuff. I would be surprised if they hadn't made any advancements, but not shocked. Oracle users are a special breed, especially Oracle DBAs. They don't want anything to change except stuff within the confines of the database. But they want to keep doing U01, U02 mount points and don't change stuff. Leave it alone. All of that stuff. DNFS, when that came out, we're not using that stuff. That's going to break everything. Made it work. And today it's probably mostly universally accepted. So there you go. All right, we got it back. Minith, let's bring you back up on stage here. Make sure everything's okay. Had a little PC crash there. It happens.
It happens. Happens at the best of times.
Yeah, right. Do you think we can share your slides again and pick up where we left off? Or do you just want to, is there anything else that we needed to get through in the slides to wrap up here? Or do we want to kind of just have a conversation?
Few things. Let me share.
Okay.
Let's see.
I was just waffling on about some of my previous history with Oracle and databases and stuff, about how we virtualized it a long time ago. Have you heard anything about, Darth had a question. Have you heard anything about some of these databases going into containers now? Like, I know you can put Postgres in a container and things like that, but I don't know if Oracle is doing anything with containers. That would surprise me.
Yeah, they will lose their main advantage that they have with disks and stuff like that. So not sure. I do not know. I would say that.
Okay. All right, let's pull the slides up here. Where we? Oh yeah, we're on the kitty cat dog picture. Okay. Yeah, we were talking about Manhattan distance and Euclid. So I was saying, I think before you're crashed, I took mechanical engineering, so I did a lot of physics and a lot of statics and dynamics and stuff like that. So I'm familiar with Euclidean distance, and I think I've heard of Manhattan distance. I don't know what dot product or cosine distance is. I hadn't heard about, or if I have heard of them, I don't remember them. So are these just statistical algorithms that data scientists use?
Correct. So same formula that you used back in college is going to be used for for searching these vector embeddings. So we'll look at a few examples, right? So we're pivoting, right, from vector database. Now we're coming to like, okay, what is vector capability within relational database? So we'll look at SQL Server, Oracle, and SAP as an example on how these traditional databases are adopting vector capability within their database. And as you know, with Copilot, if you have it in Microsoft SQL, new version, you can do natural language processing. You can say, create a table with this and this, blah, blah, blah. So that's the so-called AI aspect of it. But this is what they provide in terms of searching data, is these operators, cosine, dot, Euclidean, and how these are. So you can see right off the bat, regular users are not going to use this in any query. This is going to be helping create a data set that can be, again, further leveraged for a process or an application. So this is from Oracle 23 AI. They're providing these vector search capabilities, L1, L2. Again, not everyone's cup of tea. Mostly falls in the realm of data science on how we want to procure our data from these vector embeddings. So Oracle has more in its specialized AI 23 application, where they provide all of these features. So they are ready to adopt or attach to an embedding model, get vector tables from it, and then you can do search from it natively within Oracle. And
these are almost like middleware plugins that you add on top of as a layer on top of a database, right? And it kind of processes it into vector tables.
Different search and index mechanism introduced in your relational database for those data sets that gets passed on to them. So here's an example. How would someone use it, or how will Oracle use it? Just a query like find top 10 matching products manufactured in California based on a photo uploaded by user. And that's where the organization is going, right? Okay, show me this. Or even users, if you have used Amazon app, you can take a photo of a shoe and say, show me 10 different vendors for 10 different price, whatever the use case may be. Same thing here in Oracle. This is the query that will be used. And the operator that we'll be using, right here, is vector distance. So different use cases, different search operators will be used in these vector databases. And that's how relational databases are now adopting it. And there will be limitations for it on what can be done within these relational databases. Again, what type of search they provide, what type of indexing they provide, will determine the need of, okay, can we use Oracle for this, or can we use SQL Server for this, or can we use SAP? So this is from SAP. They use, HNSW, Index. These are the two search operators that they provide, and this is how you would use them in a SQL context in your relational database.
Oh, okay. So you can set up. Oh, okay. So something just clicked. So you can programmatically do this within the database, so that your other middleware stuff that you may choose to use can have an understanding of what's in the database. Okay. It all just kind of clicked for me. Yeah.
Now you're hand carving or creating data sets and providing to applications or end users. End users can be data scientists or other advanced level personas that can massage that data to give you what you want as part of that AI process. So yes, carving out data sets based on certain search functionality, now part of your relational database. So it's like, hey, it's in tables, we got it.
Yeah.
So who's going to use vector database or manage vector database?
Everybody.
Very niche set of people are going to use it, right? Data architects, just to understand how the flow will be from this various applications. Traditional DBA, I don't know, like maybe not a traditional DBA, but if it's a advanced DBA who can write APIs and make magic happen with programming, use Python and stuff like that, they can definitely leverage and use and adopt vector database, and they can help assist carve out that data set that is needed by either an application or a person for further data processing.
Yeah, fear not though, DBAs. You're going to be needed for a long time. Like we are going to need people that know SQL for a long time. Decades.
It's hard, right? It's coming in,
Yeah.
and then it's gonna get natural language. Like, you can dictate this, and it'll create that data set for you. So yeah, DBAs are not going anywhere.
I wonder when we're going to get Oracle GPT, or Microsoft has Copilot. Is a DBA going to be able at a select prompt or at a SQL prompt and be able to interact with an AI, kind of how you can in VS Code with Copilot? Like that's the kind of thing where you add Oracle. Like so I look at it in that context, and because I think that's the way the world's going. There's the whole assistant model that is taking over, where we have Copilot, we have ChatGPT. What's Oracle doing? What's SAP doing? Because I think while DBAs will need to be around for a while, I would say most of them are older generation. The new folks that are coming up, like you said, are Python and JavaScript, TypeScript. They're going to be writing that kind of language on the front end of things. And they may not know how to interact directly with these databases, but folks like Hugging Face and Postgres and all of these stuff makes it turnkey and stand up so that they don't have to. Their AI systems just uploads data, or their data scientist just uploads data into, and the database is built for them. I think that's the risk that traditional DBAs face, is that it's not complete replacement by AI, it's irrelevancy. And I think if you can skill up, if you can learn some of these additional, God, please go learn Python. Python is going to be everything in data science. Just go learn Python.
We're talking about advanced stuff. Advanced is like it's normalized now. There are certain expectations built in for certain skill set that you need to have. But you'll be surprised. We have seen customers who are migrating to cloud, and all traditional DBAs have the most hesitation just to change their platform. And they think cloud is some, magic. No, it's like a different infrastructure, not owned by you or hosted by you. Everything's going to be same. Yes, there are certain things that may change, but the point here is, if you are not evolving, changing, things get tough in IT. You always have to evolve, change, adopt. Basically, gone are those days where you could spend 20 years in one application and be, happy with it. Now you just have to branch out more.
But good things have also changed, Minith. And let me explain. I didn't go to Barnes and Noble and buy an O'Reilly book on how to learn Python. I went into ChatGPT, created a custom GPT, and told it, you are an expert Python instructor, and I want you to assess my skill level first, and then I want you to give me daily lessons indefinitely. And I have my own personal Python teacher that is giving me actual lessons of things code that I'm writing in VS Code, in Notepad++, things that that's how you learn now. You don't go buy the big 300-page books at Barnes & Noble anymore.
Well, you have too many blogs and videos. If you're really interested, you can figure it out, right?
Don't sleep on custom GPTs, folks. They are fantastic for learning.
Right. We got
the hype cycle here on the screen. I think people have seen this before. We've seen this before for different things. We've seen it for cloud. We've seen it for virtualization. Like, this has been a thing over the last 25 years where we've seen this stuff. So if you're not watching the video of this, you're just listening to audio over on Spotify. There is a picture here. There is video for this. Where are we at on the hype cycle for AI? This also says 2023, by the way, so it's a couple of years dated.
Correct.
Where do you think we're at?
We're right past a little bit from generative AI. So we're almost at the peak of AI hype cycle.
Okay.
And this is where people see the new shiny thing. I want. And once they have it, then they're like, oh, I have it. Fine. it'll take a while for things to, again, commercialize, get adopted in a regular, IT industry where users can interact with different applications. Right now, for some people, AI is like, oh, too complex. And, I don't know what I can do with it. Well, you're a user. You can do so many things with it,
Yeah.
right? This is just a Gartner report again, 2023. I couldn't find one for 2024, but their prediction is most of these databases of vector databases are going to be cloud-based. That's their prediction. And the reason being, when you are creating these vectorized data, there is some compute associated to it that comes into picture because it has to go through so many data and this and that. And that can be offloaded to, a vector database service provider who can vectorize your data for you. So again, use case can differ. If you want static data to be pre-populated and then you're going to use it for a while, then it's good to outsource it, get it done. If you're going to keep using it, then you want the infrastructure in-house. So many different ways to do that. They did say it's not going to be that big, but now every technology over the last 2 years, especially in AI, is leveraging vector database.
Yep.
So that needs to change. And it'll be interesting. I'll try to look for the latest one again and see if I can find it. But just like any technology, any database, same thing applies. Serverless, pod-based reads. You want to do the compute in-house versus you want somebody to do it for you. You want to host it in-prem. And with so much data being passed on from one application to another, it gets interesting on security point also. So AI and security are getting complicated from security perspective, just because it has to pass through so many applications, different infrastructures, different locations.
Well, it takes special individuals to understand the security implications of all of those different applications, all of those different services, those cloud providers, those hardware manufacturers. Like there are people in the world, and God love you for it, that eat, sleep, and breathe identity management, access security, all of that stuff. That ain't me. I am not that special kind of person. But I know a few of them, and I always point people to them whenever those questions come up.
Same here.
But yeah, you're right. The AI and security thing is going to. I think it already has. It's going to blend together and blur that line of what's accessible, what's possible, who can get access to certain things. We're kind of in a new Wild West here where we don't really know what's next. What's happening in the next 2 to 3 years beyond generative AI? We can kind of guess agentic. We can kind of guess potentially super AI. I don't know. We'll have to see what OpenAI comes up with, what Microsoft comes up with, how all of these products evolve.
They can come up with a lot of stuff. It's about adoption, right? What strikes, easiest thing is adopted. Chat GPT is the example. But then how do you make the most out of it if it's not going to help you with, revenue for your organization?
Yep. Yeah.
So, yeah. And for vector database, we can do a lot. Once it's on ONTAP, think about use cases where you have petabytes of data or terabytes of data. You can create flex clone, integrate that with another LLM. So you can have multiple LLMs connected to a single vector database, leveraging that data, and you can do fantastic things with it without, having any additional storage footprints. And that's just one example.
If you're doing model training, that would really come into, if you want to train them, if you've got a base model, a production model, and you want to spin it off into 10 different clones and throw some different things at it to inference and differently, flex clone is going to say it happens instantaneously, guys, and it costs you 150 megabytes until you write something to it in storage space. So again, just as it's always been, flex clone is flex clone. And it's now we just have a new use case, a new thing to play with it with, in models specifically. So, and that's just one of many things, many examples. Flex groups, just that automatic growth that you can get out of flex groups and performance balancing that you'll get across all of there. Object storage is going to be huge, I think. Being able to scan object stores to build models. The petabytes and petabytes of object stores that are out there in the world that are going to get scanned and built as models. I think we have grossly underestimated what we're going to be up against in the next couple of years. I don't think we have a clue what kind of power and data is going to be generated or consumed in the next couple of years. It's on scales that are bigger than anything we've seen before. So I'm excited about that for NetApp being a storage company and a data management company. But yeah, I think Minith has crashed again. So we're going to wrap things up. It's overtime anyway. I'll let you guys get out of here. Yeah, I think at the end of the day, this is important, not for you to go and learn to write select statements and build vector databases, but it's important for you to learn and understand what's going to be required of you as IT practitioners, as storage admins, virtualization, whatever niche you may be in. It's going to be important for us to understand what it's going to take to support these platforms in the near future, if not already, because the DBAs and the data scientists and application owners are going to be coming and asking for these resources. So we've got to be ready to back them up, control access, all of those sorts of things. And it's a little different than just right click new VM. It's going to require some education on our parts and some trial and error and some test runs to figure it out. So one of the reasons I wanted to bring Minith on today was because of that. I wanted to highlight vector databases specifically. We all know enough about Oracle and Microsoft SQL at this point till we're blue in the face. But vector stuff is going to become even more real as we get into artificial intelligence, LLMs, embeddings, other things, right? That's where that stuff's going to play. In the next couple of weeks, we're going to, as I said at the beginning of the show, GTC was last week. Our whole team was out there, and after an exhausting week, several of them were on PTO this week. So next week and the following week, we're going to be talking about all the announcements. We dropped like 5 or 6 pretty big announcements last week at GTC. We're going to bring people on. We're going to go over all of that stuff as we head into the summer and we start looking forwards to Insight. Yes, Insight. We're already talking about Insight. Mark your calendars. October 13th. Drew, super producer Drew, if I'm correct there, October 13th through the 15th, I believe. Thank you. Yes. So go ahead and mark your calendars. Get ready. We're hearing some rumblings. The call for papers is coming at some point soon. You know, it's about that time of year. Cisco Live's coming up. We're going to be there. Obviously, all the shows throughout the summer, we're going to be there. Cisco Live's back in San Diego, though. Nice. Excited about that. My name is Nick Howell, guys. Thank you so much for joining us today. We're going to get out of here. Thank you for being a part of the show, and we're happy to be back after about a month off. But until next time, take care.